Hello and welcome to Of Significance, the podcast about what's relevant, what's important, and what's meaningful. It's where we address whether the numbers and analytics we see daily are incredibly useful or nearly insignificant. I'm your every person host, Brent Buckwright, here with Dr. Nathan Woods and Dr. Steve Bronars, experienced experts who have been analyzing big data since before it was big. Welcome to our inaugural episode where today's topic is the namesake of our podcast. It's Of Significance, the many ways we think about it, and what it can or can't be used for. Nathan, I want to start with you. Are we pompous jerks for calling this podcast Of Significance?
Well, yeah. I mean, in the original, I think there was a question mark after it. So we were waiting for the audience to let us know if it was of significance to them or not. But, we're stuck with what we've got. We've paid for the logos. Yeah. So no, not pompous jerks.
Well, I like the feel that it's like something someone in 1704 would have written as a treatise of significance, an inquiry into the nature of numbers and statistics.
Yeah. I think we were going for some of that. I think we're also getting at the idea of talking about topics that we think are interesting. Steve and I and you have spent a lot of time talking without a microphone in our face about some of this stuff. And at some point along the way, we thought, maybe somebody else would be interested in this as well.
We might be the only people who think it's interesting to talk about the different meanings of the word significant, though.
Well,
I guess we'll find out.
In which case, we should probably start talking about what's in episode 2 right now. But, we haven't done that one yet. That
would be great if we could actually prove for a fact. If we could prove statistically no one was interested in talking about the definition of the word significance.
Well,
by releasing this podcast,
we're going to need to get into sample size. So that's
yes.
a whole different episode.
Well, significance is something we talk a lot about in our line of work, but as a term, it's complicated by the fact that it gets used in more casual conversation, I think relatively frequently. So kind of setting the table, what do we mean when we say significance?
So I think we're going to get into what we mean in the different contexts, but I do want to say we are hoping that this is interesting and important to our listeners. So that's one kind of conversational sense of the word significance. Right. We're hoping it is of some significance to them in their daily lives.
Yeah, I don't think we mean it should be different than what people are expecting it to be in a significant way. We mean the other use of the word, which is we're going to hopefully be talking about important things that people think are substantial and interesting, and that kind of use of the word significant, which we probably don't use that much when we're writing reports and even when we're talking, because it has such a specific meaning in statistics. We're always trying to find synonym, even though you want to say, oh, this is a significant result or significant finding. That implies something very specific once you start talking about the statistics of it. And so it could be an important finding or a compelling finding, but we probably wouldn't call it significant unless it met certain conditions that are very precisely defined by the statistical literature.
So people love precision. People love to hear that there's very narrow, detailed definitions of things. But what do we mean? When we say statistically significant, we mean something has some representative power based off of calculations, numbers, math. But obviously the average person, when they mean significant, they mean it's important. So is there any important differentiation in the way that we need to think about practical significance, statistical significance, some other form of esoteric significance that I don't even know exists?
Well, I think for statistical significance, that's pretty clear. You start out and you have a hypothesis about something that you're going to go out and measure, and you say, I think that we hypothesize it's going to have a value of 0 or 100 or whatever. And then you gather data, and then, based on the statistical tools that you use, you say, did the outcome that we observe fall outside a certain range, at least critical values, so that what we ended up seeing was enough different than what we hypothesized that we would say that deviation, that difference, is statistically significant. And that has to do with how much data you gathered in order to make this inference. It has to do with how much variation there is in the data, how noisy it is. The noisier it is, the more you would need of a sample, the larger the sample you would need in order to be able to say that you're confident that what you observed was significantly different than what you hypothesized. But that's really what the statistical significance means. It is really tied into doing statistical tests, hypothesis tests. And so you have some null hypothesis that you postulate, and then you gather data and you see how that lines up with what you observe.
But, if I'm looking at it in an academic way, you've got what the agreed upon body of academia uses as like a statistical significance threshold of a p-value less than 5%, or even better, less than 1%, that this is a likely outcome given the whatever sample you've chosen, right? Is that the same as in the law? Are we beholden to whose rules do we have to follow?
Yeah, this is probably a good time to say the first time among many times on this episode, we are not attorneys, so we wouldn't purport to tell you.
You can take all of this as 100% legal advice.
What's in the law? Yeah, the opposite of that. One minus that. But no, I think the standard that we see, which is I think goes back to Hazelwood and even the decisions before Hazelwood that the Supreme Court had, of 2 standard deviations being, or 2 to 3 standard deviations being their characterization of what the statistical threshold is. Now that's drawn from one particular labor and employment case involving selections, but that I think is kind of the legal standard that in our 20-something years of doing this, we've followed.
And I heard, Brent, you say p-value, and Nathan's talking about standard deviations. They're kind of saying the same thing. If you set up the hypothesis that you have, and you'd say, would this observation that I get, does it fall outside of a range of plus or minus 2 standard deviations because of a thing called the central limit theorem? That
shout out to the central limit theorem.
And again, for our audience, a whole nother episode on that coming soon.
Yeah,
that's exciting.
That's what people want to hear about.
That if you're gathering data like averages or something like that, it's going to follow this bell-shaped curve, this normal distribution, so that 5% of the time will fall outside of this plus or minus 2 standard deviation threshold. So that's really the same thing. You're saying more than 2 standard deviations away from what I expected, or you're in the tails of this distribution that you would only be in 5% of the time just due to random chance, just due to luck of the draw. And so that's when you say something is a significant difference, it's not really saying how big the difference is. It's not really saying how important it is. It's just this very specific thing saying, from a statistical point of view, it's different than what you had hypothesized it would be, enough that it would have these characteristics of being in the tail of the distribution.
So it's a numeric way of saying different enough to be noticeable. But how do I tell then what's important? How do I tell, is it significant in the kind of ordinary language sense? Is this thing meaningful?
There's a lot of different answers to that. I think back when we were writing papers, you could make an argument in your paper that it was meaningful, regardless of whether you actually hit that statistical threshold or maybe you were just short. Maybe you've got a way of talking about your data and the data limitations that would cause you to think that it was an important result for somebody to pay attention to, even if it was not significant. There's a whole, the last decade or so, there's been a lot more attention given to p-hacking, and that's more than we're going to get into in this episode. But the idea of people looking for significant results that maybe were not as practically important. So the short answer is you're supposed to look at the body of work and the result, and it's not just is it significant, but is the actual estimated difference. How far apart we are from what we expected, is that of economic importance. So you need to kind of think about that in addition to just the statistical question.
And I think the general kind of approach of statistics is that the more data you gather in your sample, the more precise your estimates are going to be. And so the smaller the difference can be in any kind of, measured terms and still be significantly different than the hypothesized value. So like it's political season. The bunch of people do polls to try to see who's supporting whom. But those sentiments can change from time to time. So they will gather information from maybe 1,000 people, and they will work out what the margin of error is. That's another way of thinking about what this is. Is there a significant difference in candidate one and candidate two? Well, the bigger your sample was, if you do it correctly, then the more likely you might be able to say that a 2-point difference, 2 percentage point or a 5 percentage point difference is significantly different between the two. And so it really, it depends on sample size more than almost anything else. And if you were going to be doing something like clinical trials, randomized control trials, which is kind of viewed as the gold standard of, hypothesis testing, you can ahead of time say, how big should the trial be in order to be able to tell whether a difference was significant beforehand? Because you go out and you run the experiment and you design it just like if you were doing a political poll, you decide how many people to sample. And ahead of time, you can kind of say what the confidence intervals would look like.
Based on expecting, I want enough power to detect a difference of at least this much. And if I know that's what I want to do, I can draw a sample that if there is a difference, we'll find it.
Right. And it's all assuming a bunch of things that we won't go into here, but large samples that are poorly designed don't provide useful information. So the classic story in all this is the Literary Digest poll when Alpha Landon, you remember that, right? 1936.
It's right there on my nightstand.
Right.
We all remember where we were.
But it was a giant poll,
yes,
but it was
classic poll.
It was based on
everyone
motor
quick
vehicle.
Gather around. The poll is about to come out. Quick, hurry!
No, it was based on people who had motor vehicles and other ways of identifying people that Literary Digest did. And it was skewed heavily towards people who were a little bit better off financially, and they were less likely to be in favor of voting for FDR in 36. And he ended up winning in a landslide, but the poll was way off. And it's because it wasn't, a representative random sample of the population.
If it's poorly constructed survey data, it doesn't, there's no statistical significance story that's going to attach to it that should be believed. Yeah. So the point there about, I think where we were going was the kind of the practical significance versus the statistical significance. And where Steve was going was, if it's a big enough sample, you could detect a statistically significant difference, even if that difference is, as a practical matter, quite small. Right.
Yes.
And so the judgment about, okay, I get it. It's statistically significant. I'm pretty sure I believe what I'm seeing. Now, do I care about what I'm seeing, or is it such a small practical difference that maybe it doesn't matter that much? That's sort of the second question.
Yeah, and I think that even though I led into this by saying it's a very precise way of thinking about statistical significance, it hinges on very crucial assumptions, like a well-designed sample. And when we're doing social science, when we're doing consulting work, when we're doing expert work as economists and just in social science in general, you're not really running experiments. And so the data that you have available to you is what we would call observational data. And so it's not as if the company or the business is saying, hey, we're trying to run experiments and make sure we have an adequate sample size to be able to test the difference between the outcomes between one group and another, or one set of customers and another.
Promotion rates or pay disparities or something like that.
Exactly. And so the data that we have to work with is what actually was what the company has been doing. And so even though it seems like, we can apply these same tools that we'd be using for randomized controlled trials and experiments that people are doing that are designing that, you have to be very careful about it, because there's going to be a tendency, there's this desire to say, I want to have more statistical power. Power is the ability to tell there's a difference between the outcomes. And so there's this tendency to want to just keep aggregating because the bigger your sample is, in theory, the more power you would have. But if you're aggregating people that are in different situations, it doesn't make any sense to really do that. So you need to work within the confines of, okay, here's a group of people that are in a similar enough situation that they might constitute a reasonable sample. And there's somebody who's in another group that's disconnected from that. It's not really true that just let's combine them together, because the bigger the sample size is, the more powerful the analysis will be. It could be totally screwed up by doing that.
So I'm a person who's interested in boundary conditions. And when we say something is practically significant, but statistically insignificant, or the converse, help me make sense of trying to think about those two concepts and what's relevant for our work or just being like a person trying to interpret numbers.
Well, I'll say one thing that comes to mind, which is that even though, because of the Hazelwood decision and this focus on 2 standard deviations, really both of those things are sliding scales, right? That it's not as if something is practically significant or insignificant. It depends on the context, right? So there isn't, I think, a well accepted, in economics at least, convention that this size of a difference we'll call practically important, economically important, and below that, unimportant. Once the numbers get small enough, then I think most people would agree, well, that's not a very economically meaningful differential. It could have been attributable to other things that we didn't perfectly control for, that kind of thing. I think there's a convention because of the court cases, and there's a convention because of the case law that followed some of the Supreme Court decisions, to have the 2 standard deviation or 5%, at least in labor and employment cases, as really being what the standard is. But I think if you looked at academic studies, depending on the study, they may use slightly different cutoffs for that.
Yeah, it kind of goes back to what I was saying at the very beginning, that you kind of put it in a context. You've got a discussion around how you hope somebody will interpret these results. And I think there's a difference between the convention applied strictly in a litigation setting, where, as we understand it, it is basically you either are at this level or you are not. And that's the whole thing. An attorney, that's the Rubicon. You cross the Rubicon or you don't. In a consulting setting, we're typically trying to alert people to areas that they might want to be attending to proactively. So that's where you might see something that you would maybe characterize as being practically important or relatively a bigger difference than something else, even if it's not statistically significant, saying to a company that's, proactively looking at its pay, hey, you might want to dig into that a little bit and make sure that that's not something that will, that is real.
And the most likely explanation of that is that when you're analyzing the differences between groups, which is kind of what we're talking about here, you haven't controlled for enough factors to really make them comparable. See, the thing about the reason why randomized controlled trials are the gold standard is because it's randomized, and you don't expect there to be any systematic differences in any other factors between who gets the treatment and who doesn't, who gets the actual drug and who gets the placebo. But in the real world, in actual observational data, there's all sorts of differences between the people in the 2 groups that you're comparing. And so it's much more important to try to control for those differences. And so even when we do see these differences, and Nathan says we should take a closer look at it, you're really trying to explain why it is that there is this difference. What are we missing in the data that we didn't have, that we'd like to have, that could account for whatever the differences are in promotion rates, pay, things like that.
And oftentimes in these more, again, consulting type proactive studies, when you give that feedback to a client, the client goes in and looks to figure it out. Many times there is an explanation that is not captured in a data field that is, something that's available to export from their systems and incorporate into the model. There's more of an idiosyncratic situation of whatever it might have been that has a backstory that you can't, capture perfectly in the model. So, I do think that's a pretty important we're talking about statistical significance. It's not as though, all models and all data analysis on which those assessments rest are equally great. And so if there's a statistical result that's resting on really poor sample of data or a really poor model, it's got other problems it's got to solve before you start getting to the statistical assessment.
Brent, I think you know this quite well, that like the standard model for any kind of selection that people start with is, let's put everybody's name in a hat and we're going to randomly select
Economists love hats.
We're going to hire. We love hats.
I thought it was a marble in an urn.
And we're going to just pull out at random we're going to hire, who we're going to promote, who we're going to let go, and a reduction in force. So if there is a significant difference in the outcomes between group 1 and group 2, maybe the thing that you're finding out is that that's a dumb model for how selections were made. Because almost certainly that's not what happened. But
right.
Almost certainly that's the first model people will look at.
People don't have big enough hats.
Right.
That's the problem.
Yeah, there are too many hats. Yeah. I think that's the problem. Well, that's good. We got that's a dumb model in on the first episode. That's good.
All right. So now wrapping up, you guys get the opportunity to give our listeners the stat pack, a takeaway of significance. What's your motivational?
Is the stat pack something we send to them in the mail, or is that them?
It's a monthly gift box that they will receive. It's the stat pack.
It contains like something that's part of a randomized controlled.
Well, it actually it contains a bunch of loose numbers that they get to assemble in whatever arrangement they want, and they can graph it and then tweet those graphs and then retweet other people's graphs, and we'll just be tweeting and retweeting stat pack numbers. You guys get the opportunity now to give our listeners the stat pack, a fun, motivational, take this away of significance, what they should know. What have you got? What's the most important thing? Is it that context is important?
Yeah, exactly. Context is important. If you're going to take something away important, hopefully you've enjoyed listening to us, half as much as we enjoy talking to each other, at least.
I think that I would just say to people to be a little bit more skeptical about what they're saying, because, and this has been said for ages, you can how to lie with statistics and all that, but the assumptions that are required in order to make these precise statements often aren't going to hold. And so you could be presented with some information that someone claims, there's a significant effect of this on something else, and it's could be caused by some factor that they didn't account for, didn't control for, didn't have information on. And so I think it's just always good to be somewhat skeptical until you can really see what information these claims are based on.
I want to take my answer back.
You've heard it here first. Stay skeptical, stat pack. Oh my gosh, that's hard to get out. Thanks for listening. Well, that's been this episode of Significance. This episode's been brought to you by Edgeworth Economics, a leader in economic consulting, and with the help of our producers, Kimberly Krewald, Ryan Deal, and Brian McLamara of Brand Ready Media, with music by Armwell Lang. Thanks for listening, Stat Pack, and always remember to check your assumptions.